Around 71% of the Earth is covered by ocean. A source of food and travel for millennia, the ocean has long fascinated humans with fantastic mythical creatures such as the kraken, Scylla and Charybdis, sirens and mermaids being part of folklore, appearing in stories and legends inspired by real-life encounters, optical illusions and imagination. Scientists have identified different layers to the ocean, and I've previously explored how you can create these in a jar. The deep sea is any part of the ocean from 200 metres beneath the waves and deeper. This area of the ocean was difficult to research for a long time. However, with the invention of three types of submersibles, remote operated vehicles, ROVs, human occupied vehicles, HOVs, and autonomous underwater vehicles, AUVs, scientists have been able to learn a lot more about the deep sea and the fascinating creatures that live there. So, here are 10 things you should know about the deep sea. 1. We know much more about the deep sea than about the moon or Mars. On a clear night, you can look up at the sky and see out into the depths of space, something you can't do with the deep ocean. This is perhaps why it has stirred the imaginations of humans, inspiring poems such as The Kraken by Alfred Lord Tennyson and the stories 20,000 Leagues Under the Sea by Jules Verne and In the Abyss by H.G. Wells. The deep sea has also been populated with large historic animals in recent Hollywood films such as The Meg and Underwater. The deep sea is often referred to as an unexplored frontier, leading to the false statement that we know more about the moon or Mars than we do about the deep sea. However, many more samples have been collected from the deep sea and many more people have visited it than have visited space. Deep sea exploration started with measuring the depths of water by dropping weighted lines to the seabed. Over time, this has been replaced by satellite data which can measure changes in the sea surface and relate this to the shape of the seabed and, more accurately, by using sonar mapping on ships. Satellites have been able to produce much more detailed information about the surfaces of the moon and Mars than the ocean, since neither are covered with water. However, the sonar mapping has now detailed just under a quarter of the ocean floor. Well, that might not sound like much. It is actually 90 million kilometres, two-thirds the area of Mars' surface and twice that of the Moon's surface. The inventions of HOVs, ROVs and AUVs, as mentioned in the introduction, have also allowed scientists to make huge leaps forward in our understanding of the deep sea. While around 600 people have gone to space, the number of people who have been in the deep ocean is in the tens of thousands. There are also around 4,000 sensor probes drifting through the deep ocean, periodically surfacing to transmit their data to oceanographers. While there is still a lot to be discovered, we have come a long way in our knowledge of the deep sea and certainly know more about it than the moon or Mars. 2. The ocean landscape is as varied as the world above the waves. Above the waves, our landscape has been sculpted by volcanic and tectonic activity, as well as erosion, with glaciers, rivers and wind playing a significant role in shaping the Earth's surface. Volcanic and tectonic activity also helps shape the ocean floor. However, there is no impacts of glaciers, rivers and wind, with the whole landscape being underwater. The ocean floor is covered by the skeletons of dead plankton as they sink through the water, covering the ocean floor in a fine mud formed of their remains. This is what forms the Great Grey Level Plains of Ooze, as described by Rudyard Kipling in his poem The Deep Sea Cables. Above the waves, our landscape is varied with mountain ranges, rivers and hills, and while there are areas of ooze, which is what deep sea mud is called, the landscape beneath the waves is also greatly varied. When undersea volcanoes erupt, the lava turns solid almost straight away as it emerges into cold seawater, forming hills that look like piles of lumpy blobs. Some undersea volcanoes reach the surface as they grow, forming islands such as Hawaii. However, most remain hidden beneath the waves as seamounts. There are more than 43,000 seamounts known around the world, and some of these rival the heights of mountains on land. There are 27 ocean trenches around the world, with 5 of these reaching depths greater than 10,000 metres. The Mariana Trench contains the deepest part of the ocean, known as Challenger Deep, which is almost 11,000 metres deep. Ocean trenches are often more than 50 kilometres wide, so from the bottom of one side of a trench, you would not be able to see the top of the other side, as it would be over the horizon. With ridges, valleys, hills, plains, mountains, trenches, slopes and canyons, the world beneath the waves is just as varied as the world above. 3. There are probably more than 1 million animal species in the deep sea. From 1872 to 1876, the HMS Challenger journeyed around the world on a scientific mission to explore the deep sea. When it returned, the hold was full of specimens from the ocean floor, which kept biologists busy for a long time, as they described over 4,700 new species, many of which were described by their skeletons, which had sunk to the ocean floor. However, there were lots of new animals too. Today, scientists continue to discover new species. As we learned in part 2, the ocean landscape is as varied as the landscape above the waves, and with such a diverse landscape, it should be no surprise to learn that there is an incredible diversity of life in the deep sea, with near invisible crustaceans drifting along past almost 13-metre-long giant squid. Muddy areas of the ocean floor are home to creatures which either burrow into it or crawl along it, like nematode worms and sea cucumbers, while rocky areas like seamounts are home to deep-sea corals and sponges. The branches of the aforementioned corals, as they grow and thrive over time, also create a home for other creatures to seek shelter in, such as squat lobsters. Among the various landscapes, there are undersea hot springs called hydrothermal vents, which are also home to a wide variety of species. In 2010, a team of researchers studying hydrothermal vents in Antarctica discovered more than a dozen species that were all new to science and are only found in that particular spot in the deep sea. By analysing the rate of which new species are being discovered, it can be estimated how many species there are in the deep sea. By doing all the relevant mathematical equations, it is estimated there are around 7.7 million species of animal on Earth, with at least 2 million of these being in the ocean. Since the deep sea makes up the majority of the ocean by area and volume, and with such a varied landscape, it is safe to assume there are at least 1 million species living down there. So far, scientists have discovered less than 200,000 deep sea species, so there is still a lot to be discovered about life in the deep sea. 4. Pressure is a challenge for deep sea species. If you've ever dived down to the bottom of a swimming pool, you may have felt a change of pressure in the form of a squeeze in your ears due to the pressure of the water above you. As you descend into the ocean, the pressure increases at a rapid pace, roughly an increase of 1 atmospheric pressure for every 10 metres down you go. That means by the time the start of the deep sea begins at 200 metres down, the pressure is around 20 times more than the air pressure around you right now, and 350 times stronger at the average ocean depth of 3,500 metres. Without protecting their bodies, air-breathing animals like humans cannot survive such pressure. This is because we have lots of gas-filled areas in our bodies, such as our lungs, which are compressible. Humans have got around this by inventing human-occupied vehicles which protect against the crushing pressure. There are other air-breathing animals which also dive to the deep sea. Emperor penguins can dive to more than 500 metres, and leatherback turtles to around 1,200 metres. The hooded seal can dive to more than 1,000 metres, the elephant seal to around 2,000 metres, and sperm whales diving down to between 1,000 and 2,000 metres. In most cases, these animals collapse their lungs instead of keeping them inflated and store oxygen in their blood and their muscles. Since deep sea animals extract oxygen from the water around them, they don't have gas-filled areas in their bodies, and solids and liquids are much harder to compress. This, however, poses a different problem for these animals. Enzymes essential for survival rely on amino acids forming the correct shape. However, under high pressure, water molecules stick to these amino acids, so deep sea creatures need an additional molecule to strip this water away. Depending on the molecule used, the depths of which an animal can reach are limited. 5. Food is often scarce in the deep sea. Most ocean food chains start at the surface, where sunlight provides energy for algae to form. Small animals eat the algae and are then in turn eaten by larger animals such as fish and even whales. At each step of the food chain, there are scraps left over from the feasting, as well as our excrement and eventually the dead bodies of the animals themselves. All of this drifts to the ocean floor as marine snow, providing food for the animals below. Lots of deep sea animals, like the vampire squid, feed on marine snow. Unlike the Humboldt squid, hunting their prey in the waters 200 to 700 metres down, the vampire squid floats in the waters 600 to 1,200 metres down, stretching out 2 of its 10 arms to catch drifting marine snow and then reeling these arms in, wiping off the marine snow to eat. Similarly, deep sea feather stars cling to rocky surfaces and stretch out their feathery arms to catch marine snow as it drifts past. Carcasses, the bodies of dead animals, are another source of food for deep sea animals who scavenge the remains for any nutrition they can gather that has not already been stripped on its descent to the sea floor. There are even 25 species of bone-eating zombie worms that use a special acid to dissolve the bones and release the nutrient-rich food inside. Some food also comes in a form that most organisms can't process. Every year, more than 3 million tonnes of wood naturally gets washed into the ocean and sinks to the seafloor, where they are met by more than 50 species of wood-eating clams that live in the deep sea, burrowing into the wood to access the cellulose and lignin food source within. This is one of the reasons why wooden shipwrecks are often so poorly preserved on the seafloor. 6. The deep sea is home to some of the most dedicated mothers. There are some species that live in the deep sea that just release their fertilized eggs out into the ocean currents and leave them to develop without providing any care for their young. However, other species take special care of their eggs right up until they hatch. In 2021, a colony of icefish nests was discovered at a depth of around 500 metres. Each nest was around 3/4 of a metre wide, and there were approximately 60 million icefish nests packed into an area the size of inner London. On closer inspection, it was discovered that each nest had a female icefish guarding a nest of around 1,700 eggs. Hoff crabs spend their lives floating around hydrothermal vents, using the minerals there to grow bacteria on their hairy chests, which they then eat. However, when a female's eggs have been fertilized and the embryo is tucked under her lobster-like tail, it is not safe for her to stay in the swarm of crabs at the vents, especially because the minerals there are toxic for the growing embryos. Instead, the female Hoff crab wanders tens of meters away and waits for their eggs to hatch. Since they are no longer in the mineral-rich waters of the vent, the female Hoff crabs go without food until their eggs hatch, leading to them wasting away, while the males still within the vents grow to 3 times the size of the females. If you think that is dedication, it is nothing compared to the octopus Granellodon boreopacifica. This deep-sea mother sticks her eggs to rocky surfaces on the seafloor and then keeps guard over them for an incredible 53 months, the longest egg brooding period of any animal on Earth. In contrast, the common octopus in shallow water broods eggs for only 4 to 8 weeks. Sadly, the Granellodon boreopacifica mother does not feed herself for the whole brooding period of almost 4.5 years and dies once her eggs hatch. 7. The deep sea is a dark place decorated with lights. There's a limit to how far sunlight can penetrate into the ocean, which is around 1,000 metres before it is swallowed up by the darkness. Although it is too dark for our eyes to see, there is still some sunlight reaching there, and this area is called the twilight zone. In the twilight zone, life is a game of hide and seek. Predators in this part of the ocean with very sensitive eyes can look out for the silhouette of their prey passing overhead. This is exactly what the glasshead barrel-eye fish does, looking up through its transparent head to spot its prey. However, this fish can at the same time look down out of the bottom of its head to watch for predators coming for it. Over 90% of the animals living in the twilight zone are bioluminescent, meaning they produce their own light, and many of them, such as some deep-sea shrimp, use this as camouflage by detecting the levels of light around them and producing a matching level of light beneath them, breaking up the shape of their silhouette to disguise themselves from predators. Passing below the twilight zone, you reach the midnight zone, where there is no sunlight at all. However, there is still bioluminescence and watching eyes. Some predators use a bioluminescent bait to lure their prey towards them, and the glowing sucker octopus actually has suckers on its tentacles which light up, directing unsuspecting prey towards its beak. Since blue and blue-green wavelengths travel furthest through the water, most bioluminescence is that colour, and it is also mostly the colour the animals can detect. The stoplight loosejaw fish, however, has a patch beneath each eye which produces a red light, allowing it to see its prey in the dark waters but not be detected by their eyes, which cannot pick up the red light. These are just some examples of how the deep sea is a dark place decorated with lights. 8. Deep sea animals use lots of senses beyond sight to survive. In point 6, we met the Hoff crab that lives around hydrothermal vents, growing bacteria on its body to eat. The females then wander away to brood their eggs before coming back again to the vent, making sure they don't go into the hottest part of the vent and get cooked. The Hoff crab, however, does not have any eyes. So how does it know where the vents are? The water that gushes out of the hydrothermal vents has a kind of odour that some deep sea species can detect. There is a shrimp that swarms around hydrothermal vents that uses 2 pairs of antennae to detect hydrogen sulfide that is dissolved in the water. This would smell like rotten eggs to us, but to the shrimp it's like a dinner bell. It is thought that the Hoff crab has a similar ability, though it has not yet been figured out how it works. There are also lots of animals that use their sense of smell to scavenge the seafloor for their food, such as a fish carcass which will produce an odour plume in the water. Deep sea fishes have ears buried in their heads, allowing them to detect different frequencies. In some fish, their ears are connected to their swim bladder, an organ that allows the fish to control its buoyancy, which can make its ears more sensitive to the sounds of predators or scavengers at a food source, while other fish have muscles connected to their swim bladder, allowing them to drum on it to produce a sound. Toothed whales, like the sperm whale, however, are the true masters of deep sea sounds. When sperm whales are diving to between 1,000 and 2,000 meters for their prey, they store air in cavities in their nose and then pass this air over phonic lips, which are similar to our vocal cords but in the sperm whale's nose, allowing it to make different sounds to echolocate its prey. That is where the sound bounces off the prey back to the whale, which you may be more familiar with hearing about bats using. The clicks used by sperm whales during echolocation can reach up to 230 decibels, making it one of the loudest sounds produced by any animal on Earth. 9. The deep sea has seasons. It may seem that so far below the surface of the water, life would not be affected by the changing seasons. However, the deep sea is connected to a whole range of changes that we notice from the land, such as tides, storms, extinction events, and even days and seasons. In the twilight zone, where some sunlight still reaches, animals may be able to detect the change in the length of day, marking a change in the seasons. In some temperate parts of the ocean, springtime results in algae blooms at the surface, which can even be seen in satellite images spreading for hundreds of kilometres. As the algae dies or gets eaten, remains drift down into the deep sea as marine snow, so there is a lot more food arriving at this time of the year, which deep sea animals make short work of eating. Not all areas of the deep sea benefit from a surface algae bloom, such as some equatorial regions, so deep sea animals in these areas get no seasonal banquet. Other deep sea animals are unaware of the extra marine snow as they already have plenty of food all year round, so the extra food once per year goes unnoticed by them. It's not just an increase of marine snow that can signal changes in the seasons, as winter storms can also be felt in the deep sea, particularly in canyons where the storm push along stronger currents of water. Time-lapse cameras also detected more fish cruising over the seabed in November, suggesting that some deep-sea fish undertake an annual migration following the seasonal peaks in marine snow. 10. Our lives have an impact on the deep sea. Although the deep sea may seem like another world, with all of the incredible advancements in human technology, we are now able to explore the deepest parts of the ocean and have this information at our fingertips. There have been websites on which you can watch live footage of deep sea research. The use of human-occupied vehicles has taken scientists to the deepest parts of the ocean, and autonomous underwater vehicles are floating around and collecting data. As amazing as it is that we can explore such places, we also need to be mindful of the impact our lives have on this part of our world. Although it may seem remote, the deepest part of the ocean is only around 11 kilometres away, which is about a 2-hour walk. It should come as no surprise then that the deep ocean is affected by noise pollution from ships travelling across its surface. Dives into the deep sea have also discovered visible items of rubbish such as plastic bags, as well as microplastics floating in the marine snow and even in the guts of deep sea creatures. Fishing practices have also extended further into the deep sea, with seabed trawling scraping life off the sea floor with weighted nets, causing incredible amounts of damage to deep sea corals which can take thousands of years to regrow, as well as risking overfishing some deep sea fish which takes decades to grow and reproduce. Deep sea oil, gas and mineral mining is also having an effect on the deep sea, with the European Union calling for a halt to the development of mineral mining until scientists can establish exactly what impact this is likely to have on the deep sea environment and ecosystems. However, climate change is having the biggest impact on the deep sea, and it is also the hardest problem to tackle. The greenhouse gases being added to the atmosphere trap heat. However, this does not stay in the atmosphere. 90% of it is transferred to the ocean, which has knock-on effects from altering the chemistry of seawater and changing the amount of food that drops to the sea floor, to lowering the amount of oxygen available for the animals that live there. There are two final thoughts I want to leave you with. 1. The deep sea has long been a remote, mysterious location, fueling the imagination of storytellers for hundreds of years. Thanks to advances in technology, it is no longer as remote or mysterious as it once was. However, with around 1 million species out there to be discovered, there is still a lot to learn about life in the deep sea. And who knows, it could be one of you discovering a new species in the future. 2. All life on Earth is connected and has an impact on each other, from land-dwelling mammals to deep-sea-dwelling zombie worms. It is important that we do what we can to help preserve and protect life on our planet. not just above the surface of the water but also below it, so that the mysteries that are there to be discovered do not end up destroyed before we can learn about them, and to ensure that all species have environments in which they can thrive and survive. Thank you for watching this Things You Should Know video. The majority of the information for this video came from 10 Things You Should Know About the Deep Sea by Professor John Copley. I was only able to touch on a tiny fraction of the huge amount of information in this book. You can subscribe to the channel by pushing the button here, and I've added a link here to my other Things You Should Know videos, and underneath to my STEM activity videos and my STEM career interviews. This has been STEM with Mr. N, exploring 10 things you should know about the deep sea.